Hi, my name is Boz Rosnan, and I would like to give you a demo about application embedding from FishTank to Axiom, joint work with David Lorenz. First, I'd like to reflect a little on the evolution of web applications. Initially, web applications were implemented on the server side with a logic tier and an application-owned database. The browser run by the user on the client side only displayed HTML content provided by the application. The Ajax revolution of the early 2000s brought JavaScript to the center stage on the client side. The role of the application changed, of the client side changed into a full-blown application where the browser assumed the role of a virtual machine running this application, sandboxing it to protect users against malicious applications. Something similar happened with the mobile revolution of the last decade, with the mobile operating system acting as the virtual machine and the mobile app being a smart client representing the application on the client side. Now, one thing to note is that the server side has not changed significantly throughout the course of the last 20 years. We intend to change that. We intend to bring an architecture to the server side that is similar to the architecture of the existing client side, with an application platform owned by a third party and served and provided as a service. The business logic of the application will reside on top of that app platform as payload, just like JavaScript code is payload on the browser. The user data will no longer be in a database owned by the application, but rather a database owned by the application platform. And all the interactions between the business logic and the data will be supervised by the application platform. We call this approach application embedding. So the benefits of application embeddings are first, separation of concerns, where functional requirements are handled by the business logic, while extra functional requirements like performance and scalability being handled by the application platform. In a way, it allows us to define applications and not implement them. The other is separation of powers. Separation of powers allows the application to be responsible for the integrity of the data it provides, while the application platform is responsible for maintaining confidentiality of user data. In a way, the platform here protects users against malicious applications. What kind of application platforms are there? So CouchDB is an application platform that existed before we started this research. It is currently in production, but it is somewhat limited in the kind of business logic that it supports. FishTank is the proof of concept that is described in the paper that we present in this conference, and Axiom is still work in progress, but it is the topic of this presentation. So if we already have FishTank, why have another thing? Why build Axiom? The reason is that they're very different in a few things. One is the architecture. FishTank uses the mean architecture with MongoDB, Express.js, AngularJS, and Node.js. And Axiom is intended to use Apache Storm, which is a big data analytics platform known to give good performance at large scale. They both implement a language named Cloudlog, but FishTank implements its basic variant, and Axiom implements its secure variant, having both integrity and confidentiality as first-class citizens. And in both cases, CloudLog is implemented as a DSL, as an internal DSL over a host language. In FishTank, the host language is Sedalian, which has a lot of advantages, but the fact that I guess most of you have never heard of it is certainly a disadvantage. And Axiom is built on top of Clojure, which is a much more popular language. So how do application platforms like FishTank and Axiom work? Well, they work with logic programming. The application platform holds all user data in the database in the form of facts and represents the business logic as a set of rules and clauses. So facts are data elements. They have a name and arguments. For example, this is a fact stating that I tweeted programming conf is fun. Rules are logic deductions that are evaluated at update time. And clauses are also logic deductions, but they are evaluated at query time. So what are we going to see in this demo? Well, we are going to implement tweetlog, which is Twitter over CloudLog. We're going to use a declarative business logic. In particular, we're going to use rules as a declarative way to denormalize our data. And we're going to use guards as a way to harness Clojure's power and to get any logic that we want into rules and clauses. We're going to handle integrity explicitly inside our business logic, and we're going to see how confidentiality is provided by the platform without us, the application providers, having anything to do with it. So the girl on the right is Moana, and the demigod on the left is Maui. And it's Maui time, or more precisely, it's demo time. So here I have two files. This is my source file, and this is my test file. My source file, in my source file, I require a package called permacode.core. Permacode is kind of like permalink applied to code. A permalink is a link that always links to the same content. Permacode is code that always behaves the same way. How do we assure that code always behaves the same way? So one thing is that external dependencies are provided using hashes. So in this case, this is the CloudLog DSL that is provided. We alias it as C, but we provide it through a hash, which means that we provide a very specific version of it. This sort of content addressable code makes sure that we always refer explicitly to one version of the code. The other is by making everything purely functional. So this pure macro makes sure that everything inside it is purely functional. For example, if I try to do a define of foo, I'll define a function named foo, which does a println of foo, and I try to compile it, it will tell me that println, although a valid Clojure function, is not allowed because it is not purely functional. So purely functional code will always behave the same way. So this is on the source file side. On the testing side, I'm using a framework named Midge. Midge allows me to create facts, which are not like logic programming facts. A Midge fact looks like this. So 1 plus 2 gives me say 4, and here you can see that this fact is not true. I change it to 3, and everything passes. So in a code where everything passes, these are indeed facts. Okay, and I have these two convenience functions that I'm going to use later for my tests. So I begin with the story. So what is a story? A story is actually a collection of facts. And these facts are not necessarily things that we take to be true. Not all stories are like true stories. So the way we construct facts is through the F constructor. And a fact is going to have the form of a tuple or a vector in closure parlance, starting with a fully qualified keyword. So the the name is going to be prefixed by tweetlog, which is the name of our application. And for example, this fact will be that someone tweeted. So let's say that Maui, this guy, tweeted, "I'm a hash demigod!" Exclamation mark. Now, since in a story we cannot take everything to be fact, an axiom, we actually we have to specify who, on behalf of whom this fact was stated. Who said this? Who logged into our system Axiom and added this particular fact? So this is called the writer's set, and it's a set consisting of identities of the different identities of the user who did that. And the minimal identity is the identity itself, so we say that this was the user Maui. This is how we specify it. So far it compiles. I'll add yet another fact to our story, and that's the fact that Moana follows Maui. And this is stated by Moana. So Moana added the fact that she follows Maui on her social media. And again, it compiles. So what do we want to learn about the story? So if we query this story, and particularly we want to query tweetlog's timeline, and we want Moana's timeline, this is supposed to give us results which are of arity 2, like 2 elements in each tuple, the author of the tweet and the tweet. And we want, and that query is made by the user Moana. So we want that to return one tuple, which is this tweet by Maui. And we have nothing because we didn't define the timeline. We haven't defined anything yet. So here we have a definition of app, which is the name of our application. It is used in our convenience functions here. So query that we called uses app as the identity of the application that we are executing. So what we want to do is to define a clause. A clause has a name which doesn't really matter. Let's call it TL1, timeline 1. But the signature or the head of the clause is this. So it's tweetlog/timeline user as the input, and as output we have the author of a tweet and the tweet. If I try to save this, it will say that tweet and author are not allowed. They're not known. That don't recognize anything. I'll just put numbers here, and you'll see that I'm getting a result, just not the correct one. Okay, so how do I get the author and the tweet? So what I do is something very similar to Prolog. I'm going to consult the facts. So we have a tweet log slash follows. So I want user to follow author, and tweet log slash tweeted, I want the author to tweet. When I try to save it, it will tell me that the rule is not secure, that tweet log follows is not checked. So what does it mean that it is, what does it mean that it is not checked? I need to add a, say, by whom this fact was stated. At this point, I'm going to say by anyone, which is my way to simply suppress this error. We'll get to that later. So now the test passes. But this is a very inefficient way to do timeline queries, because what we do is we do everything at query time. So when Moana queries her timeline, we query, well, who are the authors that Moana is following, and assume there are a few hundreds of those. Then for each one of those, we go and look up all their tweets. Now that is a pretty inefficient way to do things. A much more efficient way is to do this at update time, to create an index of the of all the tweets that are waiting to be in the timeline, in Moana's timeline. So what we're going to do is we are going to copy this and move it into update time. So we do it by doing a def rule. Rules happen at update time. We will call this followees tweets made by followees. The arguments will be user, author, and tweet. And the body is going to be exactly this. Exactly the same thing. Now, here in our clause, we need to consult the followees tweet with user, author, and tweet. And of course, we need to say that this is by someone, let's say by anyone. And the test passes. But this time, things are much more efficient. Now, we skipped integrity. So we don't care about who made the tweet and who made the follows. So there are not everyone. So in a world where everyone is naive and good, we can just take the word for it. But unfortunately, Moana and Maui don't live in such a world. And there is another creature. His name is Tamatoa. He's a giant crab who lives at the bottom of the sea, and he collects all kind of shiny objects that fall there. And he likes very much to talk about himself. So he wants to say that, to tell everyone that I'm so shiny. But what is the point in telling people or in tweeting about yourself if no one is following him? And since he's not such a nice guy, Moana doesn't follow him. She doesn't want to follow him. But he is a very clever guy, so he can make her follow him by adding this fact that Moana follows him, written by himself. And believe it or not, Axiom believes him, and you see that I'm so shiny appears in Moana's timeline. So what can we do? How can we protect Moana's timeline from Tamatoa's tweet? So the thing we need to do is to make sure that this follows fact doesn't come from just anyone, but the user. Actually, it's the user equals user. And this solves the problem. So Moana does follow Maui, but doesn't follow Tamatoa. But Tamatoa doesn't give up very easily. If he can't go through the door, he will go through the window. And in this case, if he cannot make Moana follow him, he will forge a tweet by Maui, who Moana already follows, and just say that Tamatoa is so shiny, also created by Tamatoa. And again, the crab managed to get into something into Moana's timeline. Of course, this is not what we want. So what we want is to make also the tweet, to restrict the tweet to come from its declared author. And by doing this, we block this attack. But again, Tamatoa doesn't give up. And what he does now is he goes hardcore. And what I mean, and this tweetlog.core is the namespace for our definition. And everything here, for example, follow his tweet, is defined under this namespace. So what he does is he fakes the result of the rule, follow his tweet, with Moana as the user, and this as the tweet, also written by user Tamatoa. Will it work? Yes, it did. So we have Tamatoa, I'm so shiny, in Moana's timeline. So how can we protect against this? So this is by restricting this to come from somewhere, but from where? Author or the user, the author? Actually, it's none of those. It's the app, this app. Why does it work? Because when we query, we give it the app. Everything that is propagated, or every rule that is propagated, if we look at this rule, in this rule, the in each for each fact, the rule mentions who the fact trusts to make who the fact trusts to make this statement, and at the end, the rule itself, or the application providing the rule, takes ownership over the result. So by trusting here, by trusting the app, we actually make sure that no one else can forge a fact. Okay, so we have integrity. I've shown you how we can create integrity, and now we are in a situation where we have Maui and Moana, and Moana knows everything about Maui, but Maui knows nothing about Moana, and he's all muscle and tattoo, and he doesn't really care about this little girl and her calls to save the world. So she needs to grab his attention somehow. And what better way to do this than a tweet? So she will tweet at him. Moana will tweet, "Hey, Maui, time to save the world. And this is made by Moana. So far, so good. But what would be the what do we want as the result? So what we want is for Maui to get this thing in his timeline. So if Maui makes this query, this timeline query, we want him to have something like this in his timeline. But what we wanted to say is that you were mentioned and this. So Maui doesn't follow Moana, but he was mentioned with an @ in this tweet. So we want his timeline to have this mentioning event so that he knows that he was mentioned. This is similar to something that happens in real Twitter. So, of course, the test fails. And before I make it pass, I want to comment it out. And create another test. I'm going to use a test rules with story. So what I want to do, this is it is hard to do this in just one step, because the problem here is that we need to actually go through all the tweets and just find those that have a certain user mentioned in them. And of course, this is not something we want to do when that user is looking for those tweets. So we want to do is do it at update time using a rule. So we will define a rule named tweet log core / mention, and that rule of arity 3. The user, the author, and the tweet. And we want that to give us one tuple, which has Maui as the user who was mentioned, and this tweet as the tweet that mentioned Maui. So this is what we want. Of course, the test fails. It fails with a nil because the rule was not defined yet. So let's define it. C def rule mention, and it has a mentioned user, an author, and a tweet. So how do we start it? We just pick on all the tweets, and if I try to compile it, it will say that mentioned is not allowed because, well, it doesn't know what it is. So so in order to define, to extract, so we actually want to extract users who were mentioned in that tweet, and I'll start by extracting tokens. So let's call it token for starters, and let's extract tokens. So how am I going to do it? I'm going to do it using guards. The first guard I'm going to do it is a for guard. This is simply a for form of closure, but you'll see that it does not have a body. So in closure, a for form has bindings. So we will bind token to any element in the corresponding collection, which is, so I'm going to do str split. I'm going to split the tweet based on a regular expression. In this case, I'm going to take space and some punctuation. And if I save this, you'll see that we have and plus. you'll see that we have a lot of results. We have a result for each valid tweet and for each token in that tweet. Now, I want to reduce this. I want to only take the tokens that start with an @. So what I'm going to do is I'm going to use a when guard, and the str starts with, and ask that the token only starts with an @. And here you see that we're very close to where we want to be. And all I need to do is to define the mentioned user in terms of the token. So I'm going to use a let guard, which is going to bind mentioned to a substring of a token starting at position 1. And now we have what we wanted. We removed the @. Okay, so this is it. Now I'm going to remove this rule and uncomment this one, because this is the thing that I actually want. So we want in the timeline of a user, Maui in this case, we want him to have a notification on being mentioned. So we're going to do it by creating a new clause, def clause. We will call it TL2, which is like TL1, a clause for the timeline predicate. So timeline is a predicate, and it can have a lot of clauses contributing to it. And and the body is going to be just referencing mention with user, author, and tweet, and this is done by app. And we're almost there. We still need to add this prefix for the test pass. So we're going to do this with a let guard. So let tweet be the concatenation of this string with the original tweet. And our test is passing. So we have a really cool application so far. And also Moana managed to grab Maui's attention. And then she even made him agree to help her. But the problem now is that, so Maui has this hook, but unfortunately, this guy has it right now. So what Maui does is he tweets, I just need to grab my hook from Tamatoa. And that's by Mau, which is all cool. It is added to Moana's timeline. Let's add it to Moana's timeline. Great. But we're not home yet because, well, we know there is also this guy also follows social media. And when he does, we don't want him to see this tweet because we don't want him to be waiting for Maui to come take his hook. And right now, he sees this tweet because this is exactly what our business logic said he needs to do. So you were mentioned, so it will tell him, you were mentioned in a tweet by Maui. I just need to grab my hook from Tamatoa. Ooh, that's me. Not good. I'm not going to let you do this. So I guess that Maui needs to be more careful with what he writes in social media. But in the case of Axiom, he actually has a possibility here. He can assign the reader set and restrict this particular tweet to only go to Moana. And when he does, Tamatoa doesn't see this tweet. So although the business logic said that if this tweet mentions someone, that someone is supposed to see that tweet, because applications or social networks will always want to spread information around, users in Axiom can still restrict who is able to see the fact or anything that is derived from that fact. So Tamatoa will not see this this tweet, although the application did nothing to protect the user against it. Okay, so what do we do now? Where do we go now? So now that we have our code, we can go here and do a line per permacode publish. And what we get out of it is we get a hash. So this is a unique identifier identifying our specific version of the rules and clauses that we created. So so basically what we can do with that is put it, send it to Axiom, upload it to Axiom, and Axiom will, when implemented, first do a data migration. Data migration starts with a certain rule, and it applies the rule to the facts in phases until getting all the intermediate data and all the derived facts out of it. Then, when all the intermediate data is provided for all the existing facts, it will deploy a storm topology that will maintain those things continuously. So, for example, when a user makes a tweet, the tweet goes into this topology, the tweet meets all the data about everything that everyone who is following that user, and timeline entries will be created continuously. To conclude, what we've seen is declarative business logic. We've seen how we create business logic declaratively using rules and clauses and guards. We've seen how we specify integrity declaratively as well, and how we maintain confidentiality as part of Axiom and not the business logic. If you are looking for more details, you are invited to see our talk tomorrow. Our paper is in the open access journal, and you can also visit our website at cloudalien.org. Thank you very much.